Okay, we're making some serious progress. We've got through a lot of the basics, as you might have noticed from the fact that last time we talked about how to ask questions to other people. That's a bit of a transition from what we've been doing so far, which was mostly logic and grammar, how to think, how to investigate an issue, construct an argument, evaluate a hypothesis, all activities in your head. And then last time, we talked about moving outside of your head and asking other people. We've moved on to rhetoric, that third part of the trivium, besides logic and grammar, that we would always mention, but say we'll get to it way later. Well, we've gotten through most of the basics, so later is sort of almost now. Almost. So we've covered what an argument is. It's a set of propositions which are statements that can be true or false, or a little of each, but they definitely have a truth value. We don't have to know what it is, but we could figure it out. Propositions that are connected by syllogisms, hopefully valid ones, and valid ones only, constitute an argument, the conclusion of which leads us to a new proposition that at least wasn't obvious or agreed upon or known at all before we started arguing. And the new agreed on propositions, conclusions that we generate through arguments should help us settle issues, which are just other propositions whose truth value is unknown or people disagree on it, and we decide to settle that disagreement or try to figure out what the truth value is. With clear definitions of terms, our use of language to precisely communicate logic allows us to chain propositions together, make arguments, and thereby settle issues. And our toolkit for actually doing that has a foundation of deductive logic, which is pretty much a substitution game of plugging some little statements, plugging variables of other statements into new statements, almost like algebra. Doing algebra with pieces of sentences. That's deductive logic. And it is the foundation of reasoning. However, if you stick only to pure deduction, you're not going to get all that far, because the conclusions of an argument are only as good as the premises. If you put garbage in, you're going to get garbage out. Deductive reasoning likes to stick with absolutely, definitely true, 100% certain premises. And we don't have many of those in real life. So sometimes we sort of do want to put sort of garbage in, and then we've got to deal with the uncertainty and maximize the quality of what comes out. Sometimes we have to reason from examples, and we don't know that that example applies to all instances. Just because every swan we've seen is white doesn't mean there isn't a black swan out there waiting to be discovered in Australia. And dealing with that uncertainty is a hassle, but we have to do it if we want to get much further than Aristotle. When we apply deductive reasoning to real life examples, which are questionable premises, we're doing inductive reasoning. We're basically reasoning by analogy, and we're hoping that syllogism's good. Whether an analogy is a good one or not depends on quite a few factors. The chief one is relevance. And judging whether something's relevant or not often reduces to more reasoning by experience. Do these two things consistently correlate? Is a laptop manufacturer a reliable indicator of laptop performance? Maybe yes, maybe no. Is laptop color a reliable indicator of laptop performance? Maybe yes, maybe no. And if we do more real world observation, we'll find that manufacturer, yes, relevant criterion, solid correlation. Laptop color, no, not good. Not a robust correlation, and therefore not a relevant criterion. How do we really judge whether things consistently hang together, whether a correlation is robust or not? That question's only been answered relatively recently in history, in the past few hundred years, with the invention of statistics. A lot of this logic and philosophy and critical thinking stuff predates statistics and was really in the more abstract realm of philosophy. Only recently did it carry over into science. Only pretty recently was science invented. Science got a big boost from Galileo and a few others who tried reasoning from observation, doing induction, and they found that a lot of the time the ancients and authorities were just really far from the truth. They're just wrong. And so whether it was inclined plane or dropping, whether it was gravity experiments, dropping things and see how quickly they drop, which showed Aristotle to be wrong in a lot of his physics, or Galileo's telescope work, which showed Ptolemy's geocentric solar system to be not at all correct. Galileo and a few others gained credibility for observation as as a valid epistemological tool, a reliable way of arriving at truth. Galileo didn't have some big logical theory that proved Ptolemy or Aristotle definitely wrong. He didn't know what he was doing. He was just sort of looking at things, dropping rocks, and his measurements didn't match the theory. He's like, well, maybe I mismeasured. Look some more, drop some more rocks. No, I definitely didn't mismeasure. The theory's wrong instead. So sometimes there's disagreements between observations and theories. Galileo picked some very clear-cut instances where the ancients' texts and authorities were definitely obviously wrong. But what about less clear-cut issues or more uncertain things? Is reasoning by example from chaotic observation of the real world reliable? no one really had much in the way of a solid yes answer for a long time until gambling math was invented, also known as probability theory. In the early modern period, the rich started getting richer and we had more leisure time, or at least some people did, but they didn't have many leisure outlets. So there were some people who did a lot of gambling. So we got some competitive gamblers, and they noticed that there's math. You could apply math and logic to games of dice or cards. So they would do that, or pay someone who was good at math to do that. And so they mapped out probability theory. First, it was for dice and cards, but then people started applying it to all other kinds of things. Measuring a country, statistics, in the oldest sense of the word, or making guesses in scientific experiments. We got so good at gambling math, statistics, that we became able to quantify uncertainty, make it nicely controlled numbers, almost like real math, which is a branch of logic and deductive reasoning. So with statistics, we were able to put some foundational weight into the chaotic world, messy world of real world observation, which had been scoring a few easy points against received wisdom and theory, whether it's ancient texts or religion. Galileo style natural philosophy was what they first called it, trying to achieve knowledge, or philosophy in literal Greek would be love of knowledge, trying to achieve that knowledge that you love by looking at nature. That natural philosophy was the old word for science. Eventually, we gave it its own name, not a weird new style of philosophy. Eventually, we gave science its own name, science in English. But originally, it started as the attempt to gain knowledge, Sophia, if we go to Greek, by observing the natural world. And statistics, or probability theory, gambling math, made us able to quantify uncertainty and therefore be a lot more comfortable making the jump to conclusions from some real world observed examples to a conclusion about universally true knowledge, or at least widely true. And with the tool of probability theory, we became more comfortable about applying reason, not to just abstract more reason in math, but to observations in the physical world. And that is how we invented the scientific revolution. Welcome to the modern world with all its wonders and advancements. It's really science today that produces, sometimes indirectly, all the wonders and advancements of technology in the modern world where we work. And even if we're not a computer or software engineer, we're at least using the fruits of science, such as this phone and the internet via which you'll watch this. And so far we have built the modern world, or at least the conceptual recipe for the modern world, and described the fruitful thinking processes in which we continue to operate, in which we operate in the world we've built. We're bootstrapping the future. We're as if the awesome world of tomorrow is a great computer that we're building today, or we might have hit power yesterday and today it's still in the process of booting up. Critical thinking with its more recent exponents of statistics and science is a good description of a big chunk of that bootstrap protocol. And the glorious future of tomorrow is once the machine's better booted up. Okay, that was pretty much a review. And we'll see what's next.